So we're going to find that there's a number of different ways that we can read through the file, but the most common way that we're going to read through the file is to treat it as a sequence of lines, and we're going to use the determinant loop, the for loop, to do this. And so what happens here is we get back this handle that opens the file and gives us back the handle. That handle x file is the variable I named, I just named it x file. That's not the data, but it is a sequence. It is that file handle represents to Python a sequence that we can potentially walk through and then get all the lines. And it's the simplest, most beautiful, elegant way to read all the lines in a file. We use the for loop, and we have an iteration variable. This is going to take, when we talk about the file, cheese is going to be the first line, then the second line, then the third line, then the fourth line. So it's like going through a string, but you're going through a file now and you're getting it line by line. So that's each line. I just picked a variable named cheese so you didn't get confused. Later I'll call this line, but Python doesn't know anything special by naming that variable line. Okay, and so this is, it's the for and the in, and so for, I read this as for each line in the file x, the file handle x file. So run this loop one time for every line and then print it out. So it's actually really quite simple. Okay, other languages like C or C++ or other languages, they have to write while loops with end of file conditions and all kinds of things that make this very difficult. But this is one of the prettiest things that Python has. It's a very, very pretty thing. Okay, so let's talk about what we might do. And we're going kind of back to iterations now. What if we wanted to count the number of lines in a file? Well, this is a basic loop counting pattern. So we open the file, and then like in all these loops, we do something to sort of prime the loop to get it started, set a variable count to 0, and I'm going to use the variable line that's going to go through each of the lines in the file, for line in fhand, down the file, and it's going to run this loop once for each line in the file, and the variable line is going to change. But all I'm going to do is add count equals count plus 1, and so that's just like from counters, that's just how you detect. So every time we see a line, we're just going to add 1 to the counter. We're not printing the line, we're not even looking at its data at this point. And then when the line is done, however many times it has to go, out it comes, and we print out line count equals count. And so if we open inbox.txt, this is going to do all this work and then print this line out and say line count is 132,045. So this is a little 5-line program that shows you how to count the lines in a text file using Python. Again, simple and elegant and not too much syntax for you to have to learn. Now it's also possible to read the file as a series of characters, all in one go. Read the whole file in. Now you got to be careful depending on the size of the file. This is going to lead to a string variable with a lot of data in it. Now if it's 100,000 characters, that's actually kind of a small thing. But if it was 10 million lines, that would probably not be good. You'd want to read it one line at a time and process each line and then do something. But mboxshort.txt is a small little file. So we open it and we get back a file object, file handle object, and we call the read method, and that says go through and read all the text and give it back in one big blob, one big string, and I'll put it in imp. And so that's where you have a line, a new line, a line, a new line, a line, a new line. It's not really lines, it's just a sequence of characters with new lines in there to punctuate them. And now you can split that, later we'll see how to split that into separate lines if you want. Now I picked a file that was short, and so this imp variable now has a string in it, and I can use the len function, pass a string into the len function. It says, oh, 94,626 characters. That's kind of a small little file, and perfectly okay to read it all in one go. And so now I say just print the first 20 characters. That's beginning to up to but not including 20, and so it shows the first 20 characters of that little file is a from line, because this is a mailbox file. Now, let's say we're going to do a searching, and we did this loop where you're looking for something. And so we're going to search for lines that have a prefix of from. Okay, that's what we're going to do, and we're going to print those lines out. So there's lots of lines in this file. Line, 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 from. Line, 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 from, right? On and on and on. And we only want to show these lines, the ones that match, right? That's what we want to do. And so we are going to write an open statement, and then we're going to loop through, and we're going to ask the question, if the line starts with from, print it. So sometimes it's going to skip, 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 and then it's going to run it, and then skip, 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 and it's going to run it, skip, 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 and then it's going to run it. Okay, so that's the basic idea, and then it'll finish when it's all said and done. And so this is like a criteria. This is like a search. We're looking for lines that match the string, that have the string from as their prefix. Now, when we look at the output of this, it's kind of weird. We see kind of these little blank lines that show up. Blank, 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 blank. What's going on here? What's going on? So let's take a quick look. The problem is new lines. Well, I mentioned that the file has new lines in them. And so when you do the for loop, it doesn't throw the new lines away. As you might expect, it would be kind of nice if it did, but it doesn't. It actually shows you when you read, it reads that first line up to and including the new line and gives you that back as the variable. So that is the first new line, so that means it's going to go down. And then the print statement actually adds another new line. So that's the second line of the file has a new line at the end of it, and the print statement adds another new line. So if we take a look at the code, there is a new line. Oops, come back. If we take a look at the code, this variable line has a new line in it. Oops, where am I at? I'm in the wrong slide. There we go. Yeah, this is the one I want to do. If we look at the code, there's a new line in here, and then the print adds another new line. So the print adds a separate new line. And that's how we get two new lines. The print statement's new line and the new line from the file. Here's how we fix it, and you're going to write this code a lot because when you're reading text files, you end up with a new line, and often you don't want the new line. But thankfully, as we saw in the previous chapter, there is a nice little function in Python for strings called strip that allows you to throw away white space. And to review, remember white space is anything that doesn't print. And this new line is not a non-printing character. So our strip gets rid of it. So it's a way to get rid of white space. And our strip does it from the right end. So it's the right end of the string. And so if we just are going to loop through all the lines in the file, we say line equals line r strip, and then this variable no longer has the new line at the end of it. We have our little if statement, and if we print it, then this line, the data has no thing, and then the data has no new line in it, so the print only goes down one. And so now we have single-spaced output. And so you're going to be doing that a lot. It's really common to read through a file and then just strip the new line or any trailing space off the end of that. Now, there's a couple of ways to do a loop like this, and let's just think of this as we're looking for a file with lots of different lines in it, and we want to ignore all the lines except some, say, good lines, and we want to do something with those good lines, or the lines we're looking for. Needle in a haystack. This is like searching for a needle in the haystack. So if you look at this code at a high level, we're going to loop through everything, and then we're sort of picking which lines are, and these are the good lines down here. Now often we have a bunch more code that we want to do, and we're not just printing them, but we're going to do a lot of code. So sometimes you actually structure the loop a little bit differently. And so the way to do it, and this is going to do the exact same thing, it's just a little different way of thinking about this loop. So the top part is the same, we're stripping it, and what we're doing here is everything's the same here except we add this not. If the line does not start with from, that's the translation of that. If the line does not start with from, continue. So basically we have a skipping pattern. So the lines we're not interested in, we skip. So we come down, we skip a lot of lines. And then we find a line that's good, and then we fall through. So this is the good code, and then we have all the other good code that we want to do to that line. We have that showing up down here. And so there's just two patterns, two ways to do the exact same thing. So another way to select the lines that we're interested in is to use the in operator. So we talked before about the in operator and how that works. So we're basically going to use the continue skipping method. So we're going to read all the lines, these first few lines. If uct.ac.za is not in the line, skip it. And so this is going to print out all the lines that have the string uct.ac.za in them. And so you see this is the output of the program, ... Sometimes you'll have programs that want to read different files. Often I give assignments where I say, show me how this program runs on the short file, and then show me again how it runs on the long file, just like this. And so the way we do that, to input the file name, instead of making the file name be a constant to the open call, we make the file name be a input. So we just run an input statement, which gives us a prompt, and then we type mbox.txt, and then that shows up in this variable f name. It's of course a string all the time, and we pass that into open, and then we open it, and then we do, the count operation. So if we enter mbox.txt, it counts 1797 subject lines in mbox, and if we give it mbox short, it says there are 27 subject lines in mbox. And again, this is another one of those ifs, and it's just counting, but only counting lines that match a particular pattern. Okay, so now the user can also type bad file names, and we need to be able to deal with that as well. And so we're taking a small change to the code. The dangerous code is this line right here. This line right here is going to trace back if that file doesn't exist. So what do? Well, we're going to just expand that. The rest of this program is exactly the same. The only thing's different is we've got this line. We took out insurance on it, and we know that it might blow up, and so we have it in a try and except block. So here's how the code runs. So, the input runs, we type in a good file name, it comes in here. This works, and so it skips the except, and so it runs the code and prints out the count. So that's the good pattern. The bad pattern is here, where we type in a bad file name, it comes in the try except, this file name is nanabubu, and it's going to blow up, so this line blows up, so it jumps down into the except code, prints out, file cannot be opened, so it prints this out. Now this quit is really important, because if we don't put this quit in here, it's going to continue down here, and that's going to blow up here because file handle is not defined properly at this point. And so what we have is, we have this quit is a special function where it comes in and never returns. So this is a way to terminate the entire Python program silently with no traceback. Right? So we put in our own error message, so we look like we're professional, say, oh, could not open this file, and then we stop. If you don't, it's going to come down here and it's going to trace back right there. It's going to blow up. So the quit is useful when you want to stop executing because you've detected some kind of an error. So that's a quick zoom through opening and reading through files and doing some patterns. Most of the rest of the programs in this course are going to say open for rstrip, look for, and then do something interesting. That's going to be our loop that we're going to do over and over and over again. And now we see how this looping and if and iteration and variables are starting to come together, and you can actually sort of do a program that does something useful. But before we get to too many more programs, we got to switch a little bit, switch gears, and talk up next about data structures, and that is the shape of data, and how we can use more intricate and complex variables to help solve our problems.